bear with me for a few more minutes. I'll go past. We have around 7 minutes left. Omega, M1, M2, and M3. Omega typically starts at point 0.01. Then you go to point 1, then you go to 1. Whenever you're doing underdamped systems, mark your omega n value. So when omega is equal to omega n, which is 2. Then I go to the next decade increase. Omega is equal to 20, which is 10 times omega n. You can keep going as much as you want. And then the total value of m is to be given here. Okay, so m2 is 40 log 10 of omega. So you just have to plug in the value of omega. Calculate it. M1 is a constant, so minus 18. 0.06. Okay, so M1 does not change. M2 is simple, just plug in there. When I'm at 0.01, I'm going to be at minus 80 decibels. Minus 40, 0. When I'm at omega is equal to omega n, it's 40 log 10 of 2, which is approximately 12 something, I believe. It's 12.04. 12.04. I don't need to calculate the rest of them because I know it's a 40 decibel increase for every decade. So I just add 40. 52.04. Add another 40 is 92.04. M3 is simple. M3 low all the way to omega n is 0. So the first few entries then right after I pass omega n, for every increase of a decade over omega n, I see a drop of 40 decibels. So that's minus 40, minus 80. But at omega n, if zeta is between this range, for an underdamped system, we typically calculate the peak, right? So T peak is approximately 1 by 2 zeta, because we said that the zeta square is much smaller than 1. So all those square root terms vanish. And so usually, if you have an underdamped system and if you are within this boxed range of the damping ratio, you calculate the peak at the Bode pole. So the M peak is 20 log 10 of T peak. Only for this particular range, okay? Because if zeta is 0.5, you will get this M peak value to be 0 decibels. Okay, so between this range you calculate M peak, and so M peak is 20 log 10 is an approximation 1 by 2 zeta, which is 1 by 2 times 1 by 4. And that gives you approximately minus 6.02 decibels. And so you come in and say, okay, this last column I'm going to call it as M peak. It has no entries except at omega n. Okay? So no entry, no entry, no entry. This is minus 6.02, no entry, no entry. And a very nice thing happens in this particular problem. If you look at omega n, you add this up, you add that up, you add that up, and you add that up, you get 0. Okay? but that was the purpose of the problem was designed that way. So total M is M1, M2, M3, M peak, and that's also only for the value of zeta. Bear with me for one moment. I want to draw the Bode plot. This is omega. This is M, 0. Okay? And if I add all these up, which I'll be showing in my notes, you'll get the following plot. This is 0.01. This is omega n. And you will see that if I take values after omega n, if I add them up, I'm going to get a constant line. Okay, it's always going to be minus 6.02 decibels. I just basically added all these four things up, nothing special there. This is the magnitude plot. The real plot will look something of this kind, and this is the peak that you see. This peak. That is drawn only for this particular range of zeta values. Okay? Thank you very much.